All right, everyone, welcome. Um, this is a solution video to a question where we're going to look at an example or a simulation of a log. So it's a combination log that has 0 to 49 possible values, and we can rotate to the right with each tick landing us on a number, say 1 all the way up to 49, and you can also land on 0. So knowing that the log has possible values, we're going to create a program that determines what number the arrow points depending on the number of ticks, which are the inputted values. For example, if we did 0 ticks, if we didn't move it, we land on 0, right? If I did 2, I land on 2. If I did 32, I land on 32. But here's the thing. A log has a circular arrow that spins. So if I did 52 ticks, I would actually land on 2. And if I did 172 ticks, I would land on 22. And we're trying to figure out, well, if I did n ticks, if that n value was user input, where would I end up? And that's the program that we're going to go today. And the reason I asked this question here, and we're going to revisit this later to determine if, let's say, for example, we can design a lock and see if it's unlocked or locked. But this is a first step where I'm going to teach you the power and modulus here with something that has 50 options, and we're going to see how that works. So let's get our input, and let's say ticks. We're going to ask them how many ticks. Depending on that tick's value, it's going to tell us our location. We're going to go arrow location. The arrow location is determined by ticks modulus of 50. And then we're going to print our output here. We're going to print the arrow is at arrow location. All right, so let me just explain what's happening here. Line 1117 should make perfect sense by now, but I'm going to explain line 14 and why we're doing a modulus of 50. So a combination log from 0 to 49 has 50 values, where 0 and 50 share the same location. Okay? And every other numbers from 1 to 49 are unique, that 1 belongs to 1 and 49 belongs to 49, and all the numbers belong to itself. Only 0 has two possible values, either 0 or 50 ticks, right? So far, right? So every time we go beyond 49 ticks, we're just going in a circle. Anytime you want to constrain numbers from a set range, but they're allowed to overlap themselves or go back to whatever number it should be, this is when we use modulus. So for example, if I did 50, it goes back to 0. If I did 51, we're at 1. We're at 52, we're at 2. And since we're doing a modulus of 50 and just seeing what our remainder is, if our number divided by 50 and we get the remainder, we're going to get values that are only possible from 0 all the way to a 50. There can't be any other number, but we're going to get a value from 0 to 50 and not including 50, because 50 divided by 50 has a remainder of 0. So we're looking at 49 values. Okay, so let's try this out. So if I were to do 0, arrow is at 0, right? If we do 2, we're at 2. If I were to do 32, I'm at 32. Let's do 52, the arrow's back at 2. And we could do 172, it's at 22. All right, let's try some other numbers like 177. We're at 27 now. See, we went 5 further than 172 ticks, so we should be at 27 ticks. So a modulus where we have limited set values and I should overlap every time I go over, it is a fantastic way to do that. Anything that feels circular, you should modulus. Thank you for watching. Stay classy.